Hello, this is Stephen Whitfield with Drilling Contractor. With me right now is Scott Woodruff, Vice President of the Global Oil and Gas and Mining Business at Rolls-Royce Power Systems. Mr. Woodruff spoke with us for a feature story on technologies that can aid with power and efficiency on the frac site. Thank you, Mr. Woodruff, for joining me right now.
Thank you for having me. Nice to see you.
So one of the things that we talked about for this story was hybrid e-frac system and kind of the role that they play with generating efficiency gains and aiding with sort of power savings on the frac site. So my first question is pretty general. What makes a hybrid e-frac system unique compared to other options that might be available?
So I would say the biggest feature that makes it unique is we're talking about now electrification of the pressure pumping operation. To, in the traditional or sort of the population in this space uses a transmission, drive shaft, and a mechanically driven fracking pump or a 3 to 5 piston pump. On this solution, we're talking about now electrifying the power supply and driving the pumps with an electric motor. Of course, you have a lot of conditioning of the electricity between those 2 points, but what it does is it gives you a much more wide range of performance and power, actually, to be able to increase the power density per trailer, reduce the footprint of the operation, but yet still be able to get the rate and pressure that is needed to get these wells into production. This is something that we've seen in the mining space in the mid-90s, where the large mining trucks were electrified using diesel electric power plants and then electric drive motors and what they call a traction motor. The rail industry is the same. Now that the technology for the electrification becomes more and more advanced, the control of that current is more advanced. You can do a lot more. You can control the performance of the operation and thereby the efficiency. You can run the engines or the power plant in a much more efficient state. You electrify a system, it's not variable speed. The idle is reduced. Now you're running the engine where it wants to be the majority of the operation.
So Rolls-Royce Power Systems has some experience with use cases in seeing how hybrid e-frac works in the field. What kind of efficiency gains have you seen from these solutions?
So we haven't been able to finish that. We expect quite a bit of efficiency when we look at the whole picture. And so we're still in the process of measuring some of the points compared to conventional drive systems. What you're also doing, the bigger picture by going to a nat gas electrified system here, a mobile generator, is you're also improving the efficiency of delivery of fuel to the site, how many trucks are needed to drive the equipment on the roadways, how many drivers are needed, how many people per site are needed. And so we've got the efficiency of the power plant. Then we have the additional efficiency of sort of the well to wheel by using natural gas that's located more close to the operations, that requires a lot less handling before it's used for producing the energy. The engine itself is 44% efficiency, which is very high and allows us to really run that engine, make the power with the least amount of fuel. We are still getting different solutions out running so we can start putting together the data points that say, okay, it's more efficient than compared to this type of equipment or that type, or even the different designs between different customers.
So in August of last year, Liberty Oilfield Services announced that it was using Rolls-Royce MTU gas generator sets with its DigiFrac electric frac pump system. So I guess my question would be, how does a natural gas generator like yours kind of work within that kind of system, and what kind of benefit does it provide?
So the way it works is it's a framed generator with a continuous duty engine and generator producing electricity at 13.2 1.4 kilovolts, then that electricity is used to drive the electric motors that run the digifrac pump. And so now that pump is designed to run high horsepower with electric motors driving it rather than a drive shaft, which is the traditional design that we see in the industry today. Again, you're using a lot more of the efficiency. The system is using is producing more torque and thereby electricity through the generator, bringing it to the wellhead through the pump more efficiently than the mechanical systems. I mean, so most of the mechanical systems even have couplings that are designed not to engage, so you're slipping the transmission. Every time you do that, you're also wasting power, essentially, or fuel. In this system, because a diesel electric system doesn't have those problems, you can really feed the system directly with the current and voltage. You get a much more consistent power profile. The engine runs at constant speed, so it's running at the same RPM, the load changes, but it's very consistent and quiet, so you can control noise that way. And then the hardware in between the engine and the pumps is regulating the voltage and how the frequency of that voltage and current are coming into the pump, so you can change torque quite easily and really optimize and automate how it operates every day.
Thank you very much, Mr. Woodruff, for taking the time to speak with us today.
You're welcome. Thank you, Stephen. Nice to see you again.
And thank you very much for tuning in. Please make sure to read our feature in the March-April issue of Drilling Contractor for a more in-depth look at Rolls-Royce Power Systems' work in improving frac power and efficiency.